As we all know, in SMT production, the solder paste rejection rate of placement machines is one of the core indicators for measuring production efficiency and quality. A mere 0.1% increase in the rejection rate can lead to a 3% to 5% rise in production costs, while also significantly increasing the pressure of subsequent quality inspection and rework. Among all factors causing rejection, the small feeder accounts for 25% to 30% of actual rejection issues. Below, we will conduct a comprehensive analysis from the principle and structure of feeders to real case analysis of rejection, and finally to the full life cycle management of feeders. First, we need to clarify what a feeder actually does. Simply put, a feeder is like the rice spoon of a placement machine that specifically feeds the machine. Tiny electronic components such as resistors and capacitors are precisely delivered one by one under the placement nozzle by the feeder. Here is a key figure. The feeding accuracy of the feeder must be controlled within plus or minus 0.02 millimeters. This is especially critical for ultra-miniature components like 01 or 05. Even a 0.01 mm deviation in accuracy can cause components to be placed askew, triggering constant alarms from the machine. Let's do the math from an economic perspective. If the rejection rate doubles, increases by 100%, a production line with a monthly output of 10,000 units will suffer losses exceeding $15,000 per year. This figure does not even include the cost of material waste and customer complaints. I compare these factors to 5 talented brothers, each with unique roles. This module consists of the gear set and conveyor belt inside the feeder. If it malfunctions, it is like a broken rice spoon handle directly affecting feeding accuracy. For example, the stainless steel gears used in Panasonic 8mm feeders have a hardness of up to HC60. However, long-term use still causes wear, leading to a 0.1 mm deviation each time. As a result, components shift left and right like a drunk person. Composed of a spring and a sensor, the spring acts like a rubber band. If it is too loose, the tape will slip and components will shift. If it is too tight, the tape may break. We once encountered a case where an aged tension spring's elasticity dropped from a standard 5 to 7 to 4. This caused the rejection rate to soar from 0.03% to 1.6%, and the issue was only resolved after replacing the spring with a high-strength 6.5 mm. The positioning pins and guide grooves are like a ruler, ensuring the feeder is installed correctly. If the guide groove deforms by 0.1 mm, ultra-miniature components like 01 or 05 will get stuck, similar to a small car being blocked by a speed bump on the road. An incorrect angle of the cover film can pull components like a tug-of-war, while excessive humidity can make components sticky. Last year, an electrostatic issue caused an entire batch of capacitors to stick to the tape as if enchanted. The problem was eventually fixed through proper grounding. Let's look at typical real cases of feeder-related rejection. Symptom: the rejection rate suddenly spiked to 8% with periodic component position shifts. Root cause: upon disassembly, the gear teeth showed 0.05 mm wear. The normal wear limit is less than 0.01 mm. This was like having sand stuck between the gears, causing inconsistent feeding distances. Solution: replace with laser-sintered stainless steel gears and regularly lubricate them with fluorine grease. Symptom: after replacing the feeder, the rejection rate increased 20-fold. Root cause: the positioning pin's diameter was worn by 0.04 mm, making the feed clearance 3 times the standard limit. Symptom: incorrect parameter settings led to mismatched feeder step distances. Root cause: a 4 mm step was mistakenly set to 8 mm. Components stacked like acrobats, causing not only rejection, but also nearly jamming the machine. Solution: implement QR code verification and double-person review to completely eliminate such low-level errors. We divide this into 3 phases. Every feeder has a lifelong ID that records factory parameters, applicable machine models, and other information. Just like newborns need vaccinations, new feeders must pass gear backlash testing and tension calibration, thus they fail or return directly. We have established a 3-level maintenance system. Daily basic maintenance. Clean gears with an add-on like brushing the machine's teeth. Weekly in-depth maintenance. Replace consumables and calibrate sensors like regular physical checkups. Overhaul every 1 million placements. Replace aging parts, like performing heart surgery on the machine. When a feeder has issues such as guide groove deformation or fails 3 repair attempts, a scrapping process is initiated. Usable parts from scrapped feeders are like organ donations, continuing to serve other equipment. Finally, here are 3 magic tools to improve efficiency. Modular quick change system. Replace gear sets in 3 minutes, as easy as changing a phone battery. Triple protection mechanism. Dust covers, anti-static coatings, and an AI prediction system to detect potential risks in advance. Digital management system. QR code tracing, intelligent reminders, and big data analysis keeping track of every feeder status. To manage feeders effectively, remember 3 keywords: precision, prevention, and closed loop. By controlling mechanical accuracy, implementing intelligent management, and caring for feeders throughout their life cycle, we can firmly keep the rejection rate within a controllable range. Always remember, a stably operating feeder is the most reliable comrade in arms of the production line. The above are my personal views. Errors are inevitable, and I welcome corrections from all experts. If you like my videos, welcome to follow and subscribe to my channel. See you next time. Bye.